Hello, everyone. Thank you for joining. And we've got a talk today from Benza Nagy, and it's on detecting complex code patterns using semantic grep. Hopefully you'll be interested to see that. There's a few other items that we wanted to talk to you about as well. There's some CTFs coming up that we've got. I think Mark might be ready with the dates for those.
I can't remember the date for the first one.
The first one is the 26th of October, and it's a UK-wide CTF tournament for 1 week or something.
Yes, that's on the 26th. And then we've got our own OWASP Dorset CTF on the 19th of November.
Yeah.
So we'll push more details out on our social media channels, but just to make you aware that we've got those coming up. So we've got something to look forward to. I don't have anything else from me. I don't know if you guys had anything you wanted to say before we start.
No, jump in.
Yep, happy to start.
Okay, so over to you. Yeah.
All right, and I'll just share my screen real quick. Something like that. I'm completely fine with hiding my face if that makes anything better, I guess. And should be ready. Can you give me like an all okay, just to make sure screen sharing works?
It's fine. The virtual floor is yours.
Wonderful. All right, cool. It is actually my first ever virtual meetup, so I'm really excited to try how this actually works out. And so, hi Dorset. I'm here to basically talk about this little thing that we wrote with my team. We wrote this open source project called SamGrep, which is basically like grep, but much better for searching code. And I'll just give you like a real quick, too long, didn't watch summary, so that you don't need to feel guilty if you actually are bored of me and need to just leave. So essentially what we are, like, I want to first acknowledge, though we all know this, that writing secure code is insanely difficult. So we definitely need tooling, but the existing static analysis tooling is either like slow or very noisy, not accurate enough. And also we can like search for security bugs in code with grep, but it's just like not expressive enough. So like we cannot write exactly what we are looking for with grep regular expression searches. So what we wanted to do with my team is we wanted something that's like that runs really fast, that actually understands code. So it's not just like text search, something that is like really flexible, like a Unix tool kind of flexible. So like I'm not making any promises, like we are not like a super lightweight Unix tool, but we do follow the same philosophy for composability and basically just like designing our entire tool. And it's just like we just wanted something that's like really powerful at searching code, and of course open source at that. This one thing about like flexibility and like just being fast and following the Unix philosophy is kind of like a personal gripe I have with the existing toolings. I used the static analysis tool, like a commercial static analysis tool before, where the way it worked is basically you have a web UI where you configure or all the rules that you want to use to scan your repositories. And then you can add that to continuous integration so that it keeps scanning your commits as they come in. But what it actually does during that process is instead of running some like command line tool, which would run in a couple milliseconds, right? What it did is it compiled a new Java binary for every single run with the latest rules and the latest scanning code. And like it pushes that new binary down to every single CI execution, which is like the most circumspect way you could ever do things, I'm pretty sure. And so, yeah, we are not that. We are a lot more lightweight. And so what you can use SamGrep for to like actually understand what this is useful for. Let's say you have a code base, you want to find security bugs in it, just so you know like what's the sitch, you know? You can like use SamGrep to search for common security issues in a code base. You can like guard your repository by like continuously running SamGrep all the time anyone changes the code. So that's like you get a CI failure if there's anything weird happening. You can set up, for instance, like monitoring. So even if it's not a security issue that you're finding, but for instance, if you might want to just like see any time that somebody adds a new logging line, just so you are like aware of what's flooding your logs. You could set up notifications so you get a Slack notification anytime somebody commits a new logging info or logging error, whatever you call. And the last thing is SignUp is actually able to modify code as well, so it helps with refactoring when you need to do that. And so like that was like the quick summary. If you feel like that was enough, I really hope you're not gonna leave, but pretty much you could leave and you are only gonna miss like the tutorial segments and like actually seeing this thing in action. And the other thing I wanted to mention is it gets real lonely when I'm just sitting here in my room and talking to a screen. So if anyone has questions, please post it in chat, and hopefully our wonderful hosts are going to interrupt me and ask questions as they come in. All right, cool. Here's like the obligatory intro slide. Just to give a couple words about myself. So I'm Bence, or I go by Underix online, and I'm one of the engineers at this team called R2C. My previous jobs are on the slide, but nobody really cares about that, so I'm just gonna skip that. And so I would like to talk a lot more about R2C, which is really an incredibly talented group of engineers that I had the luck of finding this year. It's a San Francisco-based startup, and the mission of the startup is basically we really just want to improve the world's code security and reliability. You do see the team over there on the right. That's a picture taken in San Francisco. Obviously, this year I have not been able to go to San Francisco at all, and I've only been at the company for like around half a year. So let's just imagine the photo would look something like that if I were there, I guess. And so what I'm actually going to give you here in this, like the actual meaty part of the talk, is just to keep things well-rounded here. I'm gonna tell you a bit about the history of SemGrep in just 60 seconds. I do want to talk about trees because it is kind of like an important concept. Well, syntax trees are important as a concept to understand like why SemGrep even needs to exist. Then most of the talk is going to be like us just learning how to use SemGrep to actually get all of these benefits for yourself. And I'm going to tell you about how to integrate this into like an actual live project CI pipeline and how you can use like our community's existing security rules that were already written. All right. So for a little bit of history, so what you're seeing here is our GitHub repository. You can actually tell that it's a mature project. Like some people jump to the star count and say like 2000, pretty mature. I think it's a much better sign of maturity that we have 5 lines here. Like the first 5 lines of the directory listing are here, and none of them are actually source code, which doesn't really happen to immature projects. It means like we're probably even like process bloated at this point. And I also wanted to like give a quick shout out to Jan, one of our teammates, who used to work at Facebook. He was experimenting on code analysis at Facebook and actually wrote the original version of SemGrep like 10 years ago to do code analysis as a Facebook internal thing. And basically, we just took over development of this open source project, and now we are maintaining it. Another thing that's like pretty important to note here is he also worked on a project called Coccinelle, which is kind of like another like semantic code refactoring tool, which is actually used on the Linux kernel itself. So like the Linux kernel developers use this tool still to refactor whenever they are changing something large. So that was the history lesson. And just so you can also orient yourself in terms of like where you will be able to use this. We do support a fair amount of languages. You can see that list on the left. Notable additions recently in maybe like the past month are a Ruby beta and a TypeScript beta. Those are actually fairly new, and I wouldn't be surprised if you hit a couple bugs, but that's why the beta sign is there, I guess. And just because, you know, open source, we do need to talk about licenses. It's LGPL, in case that's really important to someone. All right, so let's jump on to this like trees segment. I kind of just wanted everyone to appreciate how different source code is from how we perceive it as humans normally. And probably this one XKCD kind of illustrates the issue that many people who are trying to do code analysis are bumping into, where they say like, sure, I'm just going to use regular expressions. I'm going to search code. It can't be that difficult. I only need to write out like maybe 3-4 alternatives to how something could possibly be written. Obviously, it's just going to create lots of problems. In fact, instead of now I have 100 problems, I would say now I have 100 false positives. And see, that's because you, like naive regular expressions don't really understand when something is, say, a part of a code comment. So if you're trying to like write a regex that disallows eval calls, you will not actually know if the eval call is like in commented out code, or maybe it's actually part of a string that's being printed out as, hey, we are not doing an eval call here. But because your regex is going to be like dumb, it only understands text, it has no idea what this code actually means, it's going to give you like false positive results. And also, you can get false negatives as well, not finding issues that you did want to find when, let's say, maybe someone just like broke down a line of code to multiple lines and suddenly your regex doesn't even match anymore. Or maybe someone is aliasing things or using any kind of language black magic that, for instance, can happen in Python. Like in Python 2, you can even like override the value of true to be equal to false. So you can like flip these keywords, and like a text parser will never really understand what's going on. It's just going to look really weird. While what we are aiming for is that we actually understand the code and what it does. And so the really big difference here is, as a human, we look at a source code file and it looks like text, right? But what it actually is it's like a textual representation of a tree structure. And we just like convert the tree to text so that it's easier for humans to read. And what you see on the left here is actually, when parsed by machines, is interpreted as like a tree where there's like this huge hierarchy of, let's say this, there's a function definition here. There's something that belongs under the function definition, which is like the source code of the function definition. Or later there's like this set cookie call, and that's like something that shows up as a set cookie leaf, and it has various arguments under it in this like tree structure. And so that's why it just really doesn't make sense to use regular expressions to search code, because if you really want to like fundamentally solve this problem, your tool has to understand trees, which is, one could say, kind of like a solved problem, because like obviously we have syntax tree parsers, and there's like many tools that can parse, let's say like Bandit can parse Python syntax trees, and it has lots of code to detect issues in the syntax trees by looking at the syntax trees to be like entirely accurate. But the issue here is that you need like a specific tool. You need to like write an entirely new tool for every language. You then need to, on the right here, obviously you cannot read it because I don't have high resolution video encoding enough to make the source code be visible. But so what you see on the right is a snippet from GoSec, a Golang tree parsing security tool. And so they need around like 100 lines of code just to be able to find calls to old cryptographic functions. And that's definitely like when you're working on like an actual product instead of a code scanning tool, I'm pretty sure that if you like find some new security bug that keeps happening at your company or in your team, you do not have time to write 100 lines of code to parse the syntax tree yourself and figure out all of the specifics of how the tree works, and then actually write code that matches that. The other thing is, of course, there's like these commercial security analysis tools, but my point from one of the first slides still stands. Those are like right now really expensive. Obviously, commercial tools are not typically open source. There are a few exceptions, but when there are exceptions, they are typically incredibly slow, not really friendly to like running it on every single commit, and they just get like really complicated. I also want to mention this like small little spectrum that Instagram's engineering team has identified. They published this article on their engineering blog where they say that security analysis code or security analysis tools are on the spectrum of like easy and dumb, or powerful but complex, where like the easy but dumb things are like the regexes, like super simple regexes on the left side here. The whole program analysis tools, like these commercial offerings for static analysis, they're like really powerful but really complex again. And so like these open source tools that do syntax tree based linting, those kind of fall right here in the middle ground between these two, where they are like maybe not as powerful as when you do like a whole program analysis where you really like understand import chains and all of these things. But it's also definitely not as dumb as just searching text. And so if you had to ask us like where we place SemGrep, it's basically like right in the middle and this like AST-based lints. It is not all the way to the right side because we do not really follow, we don't actually understand import chains and stuff like that. Like we still only understand like one file at a time. But we are clearly like a lot smarter than regex is. And so we are right in the middle. The only major difference is that it's much, much easier to write your own customized rules with SemGrep. And I'll just show you in this slide, basically. Like our thesis is basically, like we want to let security engineers reason about the code analysis that they are doing the same way like they are reasoning about the code that is being written. Which means when you want to match something like eval request to detect when somebody is passing in unsafe stuff to eval, you can write something like eval ... in the parentheses, and that actually matches the code on the right for eval request. Obviously, it gets a lot more complicated, so I'm just going to jump into the demos and show you exactly how it works. All right. Any questions at this point? I'll probably stop for a quick second so you can interrupt easily. Or maybe we can even wait a bit in the chat to see if there's anything coming up. Yep. That probably means no. Could you give me just a sign of life to make sure that I did not disconnect and I'm not talking to nothing right now? No signs of life. Let me just look over here. Wonderful. Seems like everyone just left the room. That's completely fine though. In that case, I'll show the backstage real quick and I'm gonna have a look at the private chat here. Yeah, isn't that cool? All right, let's move on to the demos. Enough messing around. What I have coming up in the demos is, first of all, I'm just going to show you like a real quick overview of how this whole SemGrep matching, SemGrep rule writing works. Second, I'm going to show you like how you can apply this for useful stuff and practice. And there's like a couple advanced features that I'm just like too excited about not to show. So we're going to do that in the part 3 of the demos. All right. So first thing. This is like the simplest example we could come up with, which is where you just have like, where you know that like this specific function right here is banned. This is unsafe. Nobody should ever use it in your source code. So in this case, it's a Golang function called RC4, which is an obsolete cryptographic function. And we just don't want anyone to be able to use this for cryptography. But also, remember how we talked about the shortcomings of regular expression search? So for instance, when somebody just like has it as commented code, or if somebody prints the string, we do not want to match because we don't want to bother engineers with useless false positive results. And again, also like any kind of spacing should match. So for instance, this line 3 that you see here has like some really freaky, funky spacing, but we do want to match that as well. All right. I'm switching over here to this website called semgrep.dev, which has a live rule editor. What you're looking at here is, first of all, there's like a pattern that we are searching for. Right now, I just have to do return here because I'll write the pattern in a couple of seconds. And down here, we have some test code, like some code that we know is faulty and we are trying to match with a pattern or with like a static analysis rule. And so you see this is exactly what we had on the presentation. There's RC4 new cipher. That's the band function. We don't want to let people call any of this anymore. And actually, like what you can do here is just copy paste the code. So again, like we have like a really simple pattern syntax that like looks exactly like code. So if I just copy paste this, it already matches the cases where somebody calls exactly like RC4 new cipher key. It does understand that these spaces are irrelevant. These don't matter. I'll just zoom in a little bit so that maybe everything will be better visible. Cool. And the only issue is like I hard-coded what the variable name or the parameter name is as key. Like we do want to match when somebody sends in something else as well. And so what we can do here is write this magical wildcard that we came up with, the ellipsis, because as soon as I put an ellipsis in here, that just means like match anything. It's a wildcard. It's like asterisk or dot in regular expressions. And you can see we actually have 3 matches now. Anytime we call RC4 new cipher, SemGrep does tell us that like it found a match on line 12, 13, and 15. All right, that's the basics of how this works. Let's go on to some like more complex demos though. So how about when there's like an entire library that you want to disallow? So this is again a Golang example where the library unsafe, as the name probably gives you a hint already, it's kind of unsafe. Like what it actually provides is like code or like tools that go like kind of like sidestep the safety boundaries, the memory safety boundaries that Go provides. So usually in like a production application, you want to disallow this entire library. And the way we do that is, again, we're just going to go over to the live editor. Here's a bit of sample code where we are using unsafe in a couple different ways. In fact, let me just try to do the same exact pattern so we can build one step at a time off of that. It's like we had something like this before, where we disallow unsafe pointer. And if we run this, the scan shows up as having hits here and here. But there's another call here, which says unsafe size of. We want to disallow that as well. And so I'm going to introduce you a new concept here, which is meta variables. Whenever you use a $sign and all uppercase letters afterwards, it acts kind of like the ellipsis, except it holds onto this result later. So it's kind of like a capture group in regex. And what I mean by this is, first of all, we can verify that this will match everything now, because like we do have a wildcard there. But the other thing we can do is we can edit the match error message here. So like our error message right now is like a generic match found. What we can do instead is say, yo, don't you ever use func. In fact, unsafe func. And because I'm referencing the same meta variable as we had above, what happens is I can actually read what we matched as func. And one cool thing that you can do with this, I'm not going to demo the entire thing here, but you can even like have equivalences between meta variables. So for instance, if you did func equals func, then this will actually match any code where the two things, in fact, this can be x, the two things on either side of the equal signs are equal or like the same exact thing. All right, so that's meta variables. In fact, with these two things, you can already pretty much write most security scanning code that you might want for, let's say, like a 3-4 person team. But we need to go further, obviously. So one more example just to show you, like this is actually versatile. We have a lot more things than just the ... thing. Is something where we are looking for an insecure SSL configuration. Here we have keyword arguments to the TLS config in Golang. And so a pattern you can write here would look like tls.config, and then right here in the keyword parameters, we put a bunch of dots on either side to say that's like we want to match if this appears anywhere in the keyword parameters. And if we want to like go one step further, we can actually add multiple patterns to the same rule. So here I jumped over to this YAML editor, which is like the advanced way of writing rules. And what I'm going to show you now is we can have two patterns in the same rule, just like that. It's like two patterns right below, and they are inside this pattern either construct. So like either of these patterns matching will cause a finding to be reported. And so the other thing I want to disallow is any parameter where insecure skip verify is set to true. And if we do this, yep, there we go. We have two results because like both of these configurations, like the entire configuration is marked as insecure or like erroneous by having either like SSL verification disabled or using an old version of SSL. All right, let's hop on to the next thing, which is even more exciting. We're actually going to look at how to use samgrep for something like really useful rather than just these toy examples, which are really great for showing off the pattern syntax. So one thing that we know of, this is basically like a code reliability issue. Go has this concept of Go routines, and it's completely fine if you're not familiar with Golang. The only thing that really matters here is that if you have a function which only defines a Go routine and doesn't do anything else, that is going to be really unexpected to many people, because what a Go routine is it kind of like runs something in the background, and Go developers don't really like calling functions that only do one thing in the background without like explicitly having to tell it to run in the background. So the issue that we want to find here, the reliability or like maintainability issue that we want to find here, is when there's a function definition with only a Go routine in it and nothing else. So the way that works, you can probably imagine from this composition, you can paste in like an entire snippet with everything that you don't actually care about, replace with dots. So here, for instance, we added a dot to just like match any code inside this function definition, inside this Go routine function definition, or any parameters here, any source code here, and so on. And we can also kind of like compose rules by more than just like alternative patterns that could be matching. What we have here is like the possibility of like checking whether like one pattern shows up inside something else, or what we are actually using here is a not statement. So we say there is an error if there is a Go routine definition in a function and there is not any more code below it. That's like the logic here. And when we run it, or it did run actually, is what we see is it actually works. So here we have a function with just the asynchronous thingy at the very beginning and nothing else after it, but we do not get an error when there's any other code inside that function anymore. All right, so composability, super, super powerful. And another thing where this sort of like customizability comes in real handy is when you have like some custom business logic rules that you like, it's like not a standard language wide, but in your specific company, you know that the logic of the application is going to be messed up if somebody say calls two functions in the wrong order. And this like specific example that we have here, let's say we are dealing with some sort of financial transactions and the engineers planned the entire thing so that you have like a verified transaction call that you always have to call before you actually make the transaction. So you have like some kind of data integrity verification thing that must run every time before making a transaction. Of course, you cannot trust engineers to remember this all the time. So what we can do here is write a pattern. So we want to say that we want to match any time when somebody makes a transaction but didn't call verify transaction before it. That's like what these two patterns do. That's all they do. We just have like all of these dot dot dots to replace like any source code that might go here. And we say we want to match, for instance, this function definition, because somebody called make transaction, but not verify transaction. And again, if let's say somebody accidentally comments out the code, unlike regex, what happens here is we actually understand that function is not actually being called and the transaction is not being verified as it should be. Now there's one specific interesting case that I'm gonna like fix this rule right now. I basically like prepared this rule with a bug in it, just so I can fix it here with you. And what I can show you here is this one function where somebody calls verify transaction. So like it looks kind of okay, but you notice that they are verifying a different transaction accidentally than the one they are actually making. And like the rule should be that you like verify the transaction that you are making. So this is wrong. This would be correct with like verify transaction T. But so the issue here is like right now our pattern is not finding this case. And this is where those meta variables come in really, really handy. So like what we're gonna do here is all I'm changing is instead of like looking for anything in the first parameter, I'm gonna say I will capture the transaction into a capture group. And by adding it in both of them, now SameGraph is actually going to verify, make sure that the parameter passed into these two things is actually the same. Yeah, and just like that, we have an error mark on this sneaky, sneaky wrong transaction. All right, I'm gonna have a quick look at chat and nothing, no questions there. Wonderful. I can keep going, no worries. We have some advanced features. This is actually, like with this, just like seeing these couple demos, you've pretty much learned SameGraph enough for it to be like useful in your team. I don't think you need anything else, but I do want to show you some advanced features that can like make it even better. This is a kind of, it's something that we are currently experimenting with internally, which is instead of searching not for security issues, but something else with SameGraph. So for instance, in this case, we are just searching for API route definitions, which is obviously not a security issue in itself, but for a security team, it can be like really, really useful to run a search pattern through the entire organization. So you could like run this on 100 different repos, and you could get a result list of all the API routes anywhere in your entire company. And the other thing you can get is some details about these routes. So you can see what method the routes are. You can see whether there is like any kind of authentication attached to it. I'll just show you this pattern real quick. It is going to be kind of self-explanatory, but so in this specific API route definition, we just search for yeah, basically the router calls. This is going to be different for every framework, and it's going to be really easy to define your own. The real important thing here is that we are able to grab the route, we are able to grab the handler function, and we are able to grab like what HTTP verb it is, so that we can output like this textual list right here in the result set of all the routes that are defined down here. And so what we built on top of this, actually, this is like an internal thing for now, but like I would be very happy if someone contacted me about it, and I can probably show it off a bit more if someone's interested, is we have like this web app which just displays these results, but in like a bit nicer format. It's like these are all of the API routes that we have internally in our team. This is like actually powering the SameGraph website as well. And we have nice little markings which show whether authentication is required. So like wherever we saw that authentication is optional, like we just put a red mark here. It's like really easy for our security team to kind of like assess our inventory of like what needs to be protected. It's like really easy to assess your attack surface with this kind of dashboard. So that's like one of the advanced things that we built on it. This is like maybe the most flashy one that people really, really love, which is automatically fixing matches. We have another demo prepared for this one. So what we're trying to do here is fix, I believe I accidentally already ran the fix, so I'm just going to open this again. Yeah, there we go. So what we have here is a rule that not only defines a pattern, but also a fix for the issue. All it says is like, if this code matches, then the way you fix it is you find the wrong SSL version, SSL 30, and you replace it with TLS 13. So if I run this, well, it did already run. It finds that this snippet of code uses a wrong SSL version, an insecure SSL version, and we get a nice little suggestion. This is how you fix it. You just replace that one setting with TLS 13. And if you click apply fix, ta-da, code is fixed. It's wonderful. Wonderful. It is, however, in beta. It's kind of an experimental feature. It works on these cases, but you might end up finding a couple of bugs, which we will promptly fix, obviously. And the last advanced feature is maybe even a bit too advanced. What you can do in your rules is you can run arbitrary Python code on the results. So, for instance, when you're trying to verify with some like more complex Python logic that one of your matches is like a specific value or not a specific value, you can use this thingy, pattern var Python, this statement, to add some arbitrary Python code. And obviously, because it's like arbitrary code execution, it is like behind a billion safeguards. It only works if you pass this flag that you can see right at the bottom here, which goes like dangerously allow arbitrary code execution from rules. So again, this is like insecure. Only do this with your own rules ever because it's arbitrary code execution, but it unlocks some really powerful things, such as when you're verifying if an RSA key is strong enough. In this example, what we have is a little bit of a code snippet here. We are generating RSA keys, and the guidance, general guidance, let's say, is that you want at least 2000 bits of key size for you to get like an actual strong key, which is going to be like probably invulnerable to attacks. Let's say let's hope for like 10 years. And what you can do here is you obviously don't want to like write all of the possible numbers as like possible patterns that you're searching for. Instead, we have a pattern which goes like RSA generate key, and then we grab the last parameter as bits. And we have like a tiny little snippet of code, a tiny line of Python code, which verifies that this is not under 2048. So like we get an error reported, which we did actually here, when this Python line of code is executing as true. All right, so 1000 lower than 2000, that's an error, go home. All right. The next thing, again, like we basically passed the entire SamGraph tutorial. So all I have at this point are like various goodies that's like built around SamGraph to just make it even nicer to use. One thing would be the CI integration. So many teams, after seeing this, obviously want to use it to like continuously guard against security issues being introduced. And SamGraph is actually, because of this like entire Unix philosophy, is super easy to integrate into CI. First of all, the tool itself provides JSON output. So if you already have some tooling that you just want to integrate it with, you can easily grab the JSON results and just use that. But we also provide a Docker container or like an easy little Linux binary that you can just run in your CI systems. So for instance, in GitLab CI, what we recommend you do is use this Docker image that we pre-built with SamGraph and like a couple, let's say like a couple hundred extra like wrapping lines of code to make it really comfortable to use in CI. You would use this Docker image called return to corp SamGraph agent, and you just run one single line of code where you go like, let's run SamGraph agent with, let's say, the Flask config. And it runs. It actually works also in GitHub, and the screenshot is from GitHub, in fact. What it ends up looking like is you get outputs such as one pre-existing issue found, and here you go. Found some of the request data from Flask in a call to open. Now, that's no good, so it fails the build. All right. The last missing piece of the puzzle here is obviously nobody wants to write 100 different rules for all the various vulnerabilities that already exist. So another thing we have is the SameGraph registry. This is a community rule registry that we are the maintainers of. Currently, we have over 700 security rules already that have already been contributed by either us or community contributors. A notable tool called Node.js Scan is actually powered by SameGraph itself from version 4 onwards. So like this tool, which is maintained by like someone completely independent from us, basically just thought that instead of writing their own abstracts, this like syntax tree parser, instead of that, they just took SameGraph and they're using that inside their own tool to provide Node.js security reports. If you're familiar with Go or Java, you might know GoSec or FindSec bugs. So actually, we've already ported the majority of checks from there. So like we kind of like looked through the documentation, or in some cases, the maintainers of those tools were playing around with SameGraph and looked through their existing rules, and they just ported it to SameGraph rules. So you can already run those with SameGraph. One of Django's co-creators also contributed rule ideas, so we actually have like a proper community team or like a community going on here. We did get some suggestions from the Flask team as well for rules, which we integrated. And we have a bunch of security researchers who are also working with us to bring even more rules to this registry. And in fact, again, because this is like an open source thing, nothing is stopping anyone from just like creating their own rule registry, which Damian actually did. Damian is a notable Go engineer who is obviously very interested in security. So what he did is he kind of created this like Damian's Go rules SameGraph registry. You can visit his GitHub repository link. He has like a whole bunch of, I think, up for like a couple dozen rules at this point that he himself has found as like either nice reliability practice or nice security practice in Go. And so like when you go to our website and you click the registry there, that's actually just showing you like, that's just like a nice front end to the SameGraph rules GitHub repository that exists on GitHub. All right, that's basically it. This is this nice front end that I've been mentioning. You can browse like all of the language and framework rule sets that we've already come up with, or maybe I can recommend this one called R2C, which is like just our team name. It contains like most interesting rules. And then when you decide which one you want to run with SameGraph, after you install SameGraph with pip or homebrew, you can just pass one of these URLs that you get after clicking them as a config variable. All right, and in the near future, we are nearing 1,000 rules actually in the registry. That's going to be a pretty important, interesting milestone. Another thing we are working on is what we call SameGraph Community, which is a web application where you can manage the rules that apply to an entire organization on a web UI. And we are also working on like the more program analysis side. We are working on some more kind of fancy taint tracking. So like you can actually mark a variable as tainted, as in like controlled by the user, and you can write rules that just say like, don't let any user data get to this function. All right, and I think I kind of blazed past all of these slides. Again, as like closing words, you can install SameGraph with either pip or brew. And if you just want to like scan any directory that you're looking at, you can run SameGraph with the R2C config to get most of our rules. All right. Oh yeah, and of course the online editor that I've been showing for the live demos, you can find it at samegraph.live. Yeah, cool. It's kind of awkward to close a talk out like this with like not hearing anybody else, but I will just assume lots of applause and everything. We also have this little survey, by the way. Please do fill it out so that I know how my first ever virtual meetup talk went. And Sammy the Seal is actually going to appreciate that. All right. I think that's pretty much the talk.
Thank you for that, Benson. That's good.
Thank you very much for the brilliant talk.
Yeah,
If we've got any more
glad to be here.
any questions, can you post them in the comments? And then we'll get those questions fielded.
I was
Yeah,
actually
let's
wondering
maybe-
about. I do have a question for you organizers. I just there's like this, rule that you always have to put something like some local specialty or something local into the presentation. So honestly, I couldn't find much about Dorset. I'll be entirely honest with you. I'm in Budapest right now, so pretty far from there. And I just searched on Reddit and I found this picture of Sammy the Seal recently. Is it an actual thing that people over there know about, or am I like completely off the mark?
There's probably quite a few seals on the Dorset coast. So we're
Okay.
yeah, there's probably a few seals there.
Well, I liked this one specific photo, so I just put it in there.
Okay, thank you.
My talk, my rules.
Yeah.
Yeah.
So there are some virtual clubs that I just added to the stream.
Well,
Yeah.
thank you so much, Ninja Nugget.
Are there any questions, guys?
We've got a
Now it's the
question
time
from
to
Ninja Nugget.
add them to the comments sections, to the chat section. I mean.
So we do have a question from Ninja Nugget. Can you see it, Alex?
Ah, right. It just appeared in my screen.
How would I advise a beginner to start learning SamGraph? I feel like you are doing quite well already by having watched this talk. You can probably write simpler rules already. And I think that the least effort, the lowest cost way of getting into SamGraph rule writing would probably be going on samgraph.live, this live editor that I've been showing. As like the simplest example, you can just like drop in like a print hi into both the code and the pattern boxes, which will just like match itself, obviously. And I honestly just recommend that you like start playing around, use it kind of like a sandbox and start playing around with various like source code to look through maybe the examples that are provided there. There's like a button that says examples, so you can go through more examples than I could in this 45 minutes. And that's pretty much it.
Thanks. We haven't got any more questions coming in. Thank you for that.
Cool. Well,
Yeah.
I've got some questions for you, Spencer. So you mentioned about the rules. So you've got pre-existing rules. Do you guys
Yeah, that's
validate
right.
those rules? Or are they
Yes.
just community rules?
So when I called it as like we are maintaining this registry, what that means is we actually have a team of 3 or 4 people at this point who are like taking care of all of these rules. They are looking at the rules, filling out all the metadata about them. So we are actually like cataloging the rules in terms of like what OWASP error they are, or OWASP top 10 issue they are finding, or what CWE they are finding. All of this cataloging is done by our team. And we also have like unit tests written for all of the rules. Yeah, I don't even get into that, but we have like this whole like rule testing system for it. So I would say the registry is in pretty good shape. Yeah.
Cool. So another one then. So how could people contribute if they wanted to? Where should they
Yeah.
go?
That's a really great question. I always love hearing this question because contributors always super appreciated. There's like a couple different layers where we are accepting contributions, right? So like we have the super hardcore code analysis, source code parsing, syntax tree parsing code, which is written by OCaml, and I could never understand anything of what's going on there. So if you want to contribute to that, which is very rare because very few engineers are as hardcore as Johan that I talked about earlier, you could go to the repository that we have for SamGraph. That's return to corp/SamGraph. I mean, honestly, you can just Google SamGraph or go on samgraph.live and you will find the GitHub repo. right there we have contribute like this file called contributing.md, which is kind of like an open source standard at this point. It describes exactly how you can set up like a development environment, how you can, I think it even mentions how you can pick an issue that you can work on from the issues list that we have on GitHub. And the same actually goes for the less hardcore, but still really fun layer, which is a Python command line utility. When you're actually invoking samgrep on the command line, that goes to a Python application, which understands like, for instance, the rule YAML files, the interactions between different patterns in terms of like pattern yes, pattern not. It understands all of these things. It obviously also executes the Python, like the inline Python scripts or codes that you can add as part of a rule. So there's like that whole Python thing. My advice on that layer is the same as before. And in fact, an even more cool thing you can do is join our Slack channel, because we have a Slack community where I think pretty much anytime we are like, our team is at this point like really around the world, and we can just like hop on Slack, answer questions about contribution anytime. And yeah, that basically goes for rule writing as well. If you want to write rules, hop on our Slack. We're just gonna help you out. And that's basically it.
Cool.
Yeah.
Can I ask, do you plan to have any integration with like sticks so you can start reporting stuff that you found?
With
So
sticks?
Yes.
That is actually not something I've used before. I assume that it's some sort of like a meta linter or like some security tool that gathers security
It's
scan
basically
results.
a format so you can exchange, let's say, threat intel. So maybe you can say, okay, I found this with on this code, so I have to start sending messages about this.
Yeah. So when you say it's a
not the same
format,
approach. I'm thinking of the bigger picture of how you can place it.
yeah. So for like a bigger picture of what you can do with the results, first of all, we are already pretty extensible because we first of all support JSON format for all of our output. It's very easy to like use existing tooling to just like read a JSON list of findings, for instance. We also support SARIF format, which is a static analysis standard format, which is used, for instance, by GitHub security scanning and all sorts of tools that will already like readily integrate with samgrep, just because they understand the exact JSON fields that we are outputting. That's one like method of integration. And the other thing is we have like this kind of homegrown environment for this thing that I mentioned at the very end briefly, samgrep community, which is something in private beta right now. It's like a web application for handling the entire flow around all of your results, which includes sending Slack notifications, for instance. If you reach out to me and ask for access to the private beta, this goes, of course, to like everyone in the audience. I can probably approve your private beta access, and you can already like use this to get Slack notifications about any finding in repos. You can use this very soon to get like Jira or email notifications, to see like reports on like a visualization of like your security findings over time and how long it takes to resolve them and all of these things. So that's like the other piece of kind of like extending from the CLI tool.
We've got another question that's come in.
Yep.
Oh, cool. What specific examples of source code would samgrep particularly improve for security? Let's see. So the ones, obviously my head is like full of the ones that we just went through on the demo. The cool thing is that in the registry, so if you look in the GitHub repository where our registry is with like 700 different rules, I think every single one of those rules have sample source code that is faulty. So if you just want to like learn about like insecure code, like what insecure code looks like and what kind of pieces of code can be improved in terms of security, you can go through the return to corp/samgrep-rules repository, and it's gonna have like lots of example snippets for this. And specific examples, one thing that we have in our company, and this is like something we did last week or maybe like 2 weeks ago, we found out that SQL Alchemy or SQL Alchemy, this database library that we are using in Python, is by default logging all sorts of secret tokens or passwords to our regular logs. With like no regard for security. It just like outputs when we are inserting a token, for instance, into the database, it just outputs the exact token to our logs. So we changed it a slight bit. So like we practically like wrote a plugin for this database library for our company. Like this is like a company internal thing, which masks out secret values in the database. But our engineers always have to remember to use the plugin which is masking out secrets. So what we ended up doing afterwards is we wrote a SAMGRAPH rule which checks if basically like matches any code where somebody is using this database library with any column that has a name like password or token or secret, like matches the name of what column you are requesting with it. And it requires that you use this more secure plugin that we wrote for masking the secrets if any of those scary words are encountered. So this is something that we rolled out across our entire organization by like after, I don't know, like 20 minutes of work maybe. We just needed to write like this small YAML rule, like when the column name is something token, this must be here. This secure plugin must be here. And now we like anywhere in our entire company, nobody can commit that mistake anymore because CI will just block it. So that's like one example. Pretty cool one at that.
Yeah.
A specific example I am thinking of, more questions by Ninja Nugget. We're going to be best friends after this, wonderful. Specific example I'm thinking of is a dashboard. Is there any faulty source code examples in the registry associated with this at all? I'm having a tiny bit of trouble parsing the question. Sorry about that. So like the way I understand it is you have a dashboard application and you want to know what kind of security bugs can happen in a dashboard. Well, that's how I'm going to interpret the question. And in that case, let's see. So first of all, if it's a dashboard, there's probably a web application which uses JavaScript or TypeScript. So first of all, you have the language support there. That's good. And there are much better resources for this than I am. There's like many lists of like various kinds of security vulnerabilities. I would recommend Googling OWASP top 10, which is like one of the golden lists of what security vulnerabilities exist. But for instance, one of the things you would need to be worried about is, say, if your dashboard has any kind of like filtering or clicking around to like show different kinds of data, you might accidentally through that allow access to the person who is setting the filters. Like if a user is able to set filters, you might accidentally be allowing them access to modify your database, delete your records, select anything from your database. This is called SQL injection. It's actually on this OWASP top 10 list. And that's a really bad one. You really don't want random users to be able to write to your database. But that's like one of these things. And SAMGRAPH is able to figure out whether on the back end of this dashboard, you are accidentally passing user input to database queries without sanitization, of course. So like basically SAMGRAPH is able to check if you inadvertently gave the user access to your database. Yeah. And we also have a question on whether I am planning to share the slideshow. Yes, I am planning to share the slideshow. I just need to figure out how to do that. It's the first time I'm using Google Slides, and I can probably download a PDF.
You can export the file, and we can post it.
Yeah, I was going to ask exactly for that. So I'm going to send our hosts over here. Probably I'm going to send it to you, Alex. I'm going to send you a PDF, and you can post it on the Meetup group.
Of course.
Wonderful. So that's where you're going to be able to find the slides.
I don't see any other questions, but we can wait for a couple of seconds.
Yeah, sure. Yeah, I can sit around. Not much to do tonight. I do believe no more questions are coming in.
Yeah.
All good.
So I think we'll close it there. If that's
Brilliant. Do you guys think it's time to call it a night? Say goodbyes?
So we'll let people go and have their dinner.
yeah, we just got a comment. Okay. Thanks for your help.
Yeah. I also wanted to say thanks. Thank you so much for the opportunity to present here and to be my first audience on a virtual meetup. You actually made it really great. I really love the setup here in terms of tech.
Well, the pleasure was ours. Thank you very much.
Yeah,
That's
Yeah.
good.
thanks. And see you, audience. Bye.
So, good night all. Bye now.